Hello everybody, Unit 4, Day 6. Now we're bumping up our skills here, right? We're doing operations with radicals. So if you're watching this, maybe you needed a second reference on what we did in class today, or if you're one of those unlucky individuals, you're probably stuck home. Unfortunately, you're just going to have to watch this video and then try the problems on your own. Okay, I'll upload an answer key for this tomorrow. Okay, so you'll have access to that and you can excuse me, try these problems and then utilize the key to, see if you got the same answers I did. Okay? So anyway, not a very long lesson today. We're only going to get through a handful of problems, and so hopefully this video doesn't take too long. I'll try not to rush through it. I'll do the best I can on that, and sometimes I find myself going too slow, right? So, I don't know. Just trying to find that middle ground. So anyway, simplify. You got it, right? Don't know why I made that so big. Okay, so what is this equal to? We're looking at the square root. Let's start with that first piece. The square root of what do we have underneath there? Well, this is a to the 2/3 power. Okay, well, we're taking the square root of that. So really what we're doing is we're taking that a to the 2/3 power and then raising it to the 1/2 power. And so then multiply those exponents. So we get a raised to the 2/6 power, which can be simplified to a to the 1/3, which you could either leave as that, or if you want to write it like this, that's correct as well. Okay? Or maybe you want to write it like this. You don't like that 1 under there. Okay? I'll never mark you wrong for the 1, or I'll never mark you wrong for putting 1x, right? I feel like that'd be stupid because technically you're correct, right? But, for mathematical purposes, right, we always try to make things look a little simpler, right? So in retrospect, we make it look harder because then there's stuff that's not being seen. But anyway, that's a whole other conversation. So this is what we're doing. We're going to be simplifying these radicals and then doing operations with them. So before we can do operations with the radicals, we have to make sure everything is simplified. So that's going to be our first step in all of these. So kind of continuing or piggybacking from yesterday's lesson or the day before and then carrying on operations. So today we'll be doing operations, addition, and subtraction. When you guys return, we will do multiplication and division. Okay? So anyway, what do we got here? Well, it's telling us to set this up. So if this is equal to this, and a is constant, what is the value of a? Okay? So what it's asking for is to simplify like we did in number 1, and then whatever that exponent we're left with, it'll be x plus 1 raised to some power, and that will be our answer. Okay? So let's start with the first piece, right? So square root of x plus 1 raised to the 5/3 power. All right, well, that's just equal to x plus 1 raised to the 5/3 power, raised again to the 1/2. So I multiply that through, so I get x plus 1 raised to the 5/6 power. And so our answer, A, is equal to 5/6. Let's take a look at number 3. All right, use the properties of exponents to determine the value of y. All right, so again, just like we were doing up above, we're just trying to find the value of that exponent. So what we're going to have to do first is we're going to have to adjust these guys. We're going to have x to the 8/3 all over. I'm going to multiply that power through, so I'm going to get x to the 4/3. Okay. And so we got the same base here, and we're dividing with exponents, right? So what happens when we're dividing and we have the same base? What do we do with the exponents? We subtract them. So luckily for us, we got a nice common denominator. All right, so all we got to do is just do the math. So our answer is x raised to the 4/3. And so y is equal to 4/3. Okay, example 4 isn't as nice because when we go to adjust this, we're going to have x to the 2/5. This one down below is going to be x to the 1/4 raised to the 1/2. Okay? And once we simplify that, we get x to the 1/8. All right? So again, same base, we're dividing. What do? We subtract the exponents. Okay? And so, because I'm feeling lazy, I'm going to go to my calculator. All right? I am totally confident I could do this without, but being, this is a Regents course, sometimes it's just nice to save yourself some time. So when you plug this in your calculator, you get x raised to the 0.275, right? And then you're just going to hit math, frac, okay? And so we get x is equal to 1140. Okay? All right. So, adding and subtracting radicals, okay? Radical expressions are like radicals if they have the same index and the same radicand, okay? So what that means is they have to have the same everything, all right? That needs to have everything in common, okay? So, your radicand, if your number inside is 3, 5 squared, right? Well, in order to add that, we would need to make sure that the other guy is 3, 5 squared, right? So everything has to be the same inside that parenthesis. So if we have 3x squared, and I wanted to add another radical, we would have to have those same things. And then 1 cube root of x squared plus another 1 cube root of x squared will give me 2 cube root of x squared, right? Because how many do I have? 2. So, anyway, getting ahead of myself, but that's what we're looking at. We're looking at to make sure that everything, the index, and then what you have inside the radical is the same. And on top of that, you also have to make sure they got all the same variables as well. Okay? So, that being said, let's head down to 1. So number 1, let's head over to number 2, right? Let's start with number 2, right? So number 2, okay, as you can see, right? And also, real important here too, guys, the reason why all this stuff has to be the same is because let's take a look at this guy, right? We would never add these guys because we don't have like terms, right? We would need either this to be both x squareds or then both to be x. You can't have one and another and add them together, right? Same thing with these radicals, right? If I have x to the 1/2, right, plus x to the 1/3, right, those aren't the same exponents, right? It's not the same, so we can't just add those guys, okay? So those are completely different, like, terms. All right, so we can't add this and this, okay? Can't add those guys. All right, so we need to have everything kind of the same. So this first, number 2, right? We have a y raised to the 1 cube, y raised to the 1 cubed, or 1/3. We have an x, and so in this case we just subtract the numbers, right? We say we have 2 of this guy right here minus 7 of this guy right here. So how many of this guy do we have? Well, 2 minus 7 is -5 xy to the 1/3. Okay? So let's jump back to number 1. Okay, number 1, right? We can't add those guys yet because we don't have the same thing underneath the radical, right? And this one's got an xy out in the front, so we got our work cut out for us. So let's see if we can get these guys to match up. And full disclosure, all of these you can add or subtract, okay? So anyway, all right, let's just hockey stick method this guy here, right? So hockey stick, bring out a 2, boom. All right, let's see. We have a 2 here, right? So how many x's can I bring out? Just 1 with a remainder of 0. And then 2 goes into 5. How many times? Twice with a remainder of 1y. So there is that minus x squared, or xy squared, square root of 2y. So finally, I got 2 of this guy right here minus, you don't see it there, but minus 1 of these guys right here. So I got 2 of this guy minus 1 of this guy, which will leave me just 1 of this guy. Let's jump down to number 3. Number 3. Okay, again, we need to make some adjustments. Right? These are just square roots, right? Our index is just 2 there. Okay, so in this one, right, 2's already kind of stuck there, right? It's already a perfect square, or I'm sorry, already a prime number. So 2 just hangs out. Now, how many times does 2 go into 5? Well, that'd be twice with a remainder of 1x. And again, if you write all the x's out, okay, how many pairs of 2 do we have? 2 with 1 left behind. Okay, now minus. Okay, so we don't have the same thing over on the other side either, right? We're going to have to hockey stick method this 18 here, right? So square root of 18 will give me 2 and 9, 3 and 3, hockey stick. Bring this up a bit. Okay, hockey stick. So we end up bringing out a 3 and the remainder of 2 in there. Okay, so we're going to have 3x with the 2 inside, and then again our index is 2 here. How many times does 2 go into 3? 1, so I'm going to bring out another x with a remainder of 1. And now I have 5 of these guys minus 3 of these guys, and these guys are the same, right? X squared square root 2x. So our answer is just 2x squared square root of 2x. Let's take a look at number 4. Okay, so hopefully I can start getting you guys thinking like this. All right, how many times? How many times does 3 go into 4? Right. So again, the only thing that's being affected by that 4/3 is the x, not the 2. Okay, so the 2 stays right here, and so we're going to have x to the first power with an x behind. Let's see if that makes sense, right? If I were to write it like this, okay, we're looking for pairs of 3, so I'd bring out 1, so I'd have 1x with an x behind. Okay, and then minus 3x with the same exact thing, cube root of x. Okay, so I got 2 of these guys minus 3 of these guys, which will give me a negative 1 of those guys. Okay, number 5. All right, so this is x, y raised to the 1/2. Okay, all times 3 plus xy square root of xy. Okay, so we're going to multiply this through. Okay, so we're going to have xy to the 3/2 plus xy square root of xy. Now I will tell you, this thing right here is equivalent to this thing. All right? It is. True story. All right? So how do we get there? Well, go a couple ways about it, right? No wrong way to eat a Reese's here. So let's rewrite this, guys. So we're going to have xy cubed with the 2 on the outside. Okay? So let's jump through and put that 3 on both the x and the y variables. So that's going to be a 2. So this is going to be x cubed, y cubed. Okay? So how many pairs of x's can I bring out? Well, just 1, right? With a remainder of 1 behind. And then same thing with the y. I can bring out 1 with a remainder of 1 behind. And so there is our answer. And so if you didn't like that, or if maybe that's too slow, you can look at it as, okay, how many times does 2 go into 3? Once, with a remainder of 1, of whatever that thing in parentheses is. So therefore, 1 xy square root xy plus another 1 xy square root xy will give me 2 xy square root xy. Okay. And then finally, this last problem here, okay? This is called the product property. All right, so the product property states this. Okay? Square root of xy is equal to the square root of x times the square root of y. So we're going to use that property in order to separate this guy right here. So 5 times square root of x times square root of y plus 25 square root of x. And now we're looking at a GCF here. Okay? So what is common in both pieces? Well, you have a 5, right? So I'm going to take out a 5. And then we also have a square root of x in each piece. So I'm going to take that piece out. And what do I have left with? Square root of y plus 5. Now let's see if we have one of those answers. Well, that ain't it. That ain't it. This one's close. We don't have a 25 out there. So it's got to be D. But why is it D? Well, all they did, just because they're mean like that, is they just switched that to a 1/2 times y to the 1/2 plus 5. Okay? So remember that this guy is equal to this, and that guy is equal to that. Okay? So hopefully that helped. Okay, your homework is the odd problems. Okay, so not a whole lot, only 7 problems for homework. So hopefully this video kind of guides you. Be looking for an answer key later this evening, possibly tomorrow morning. And yeah, good luck, you guys. I'm sorry you're quarantined, and if you're not quarantined and you're rewatching this, well, shame on you, because I taught this lesson in class.